Okay, this is a worked example for a continuous probability function. It's got the shape of a sawtooth, hence the name in the title. Let's have a look. Continuous random variable x has probability density function f of x given by f of x equals 2 into x minus 2 for values between 2 and 3, else it's 0. So we can draw that. I mean, it's a straight line, isn't it? 2 into x minus 2. So we only need 2 points. If we substitute 2 and 3 in there, we get 0 and 2 respectively. Connected, therefore, by a straight line. So this is what it looks like. It says for all values of x. Well, we've done the relevant values and a few more besides. I wouldn't say we've done it for all values of x because we don't know how wide to go, but anyway, that's what the question says. Part B says write down the mode of x. Right, the mode of x. Well, the mode of x, the mode of a discrete probability function is the value along the bottom that gives you the highest bar, if you like. Sort of same thing here, really. It's the x value that gives you the highest value of f of x. And that is 3. So that's the mode. Mode is equal to 3. Part C says, find the expectation of x. The expectation of x being the sort of the mean of the random variable. If you think again to the discrete case, what we do is we multiply every possible value by the probability of the random variable taking that value. We add all those up, we get a kind of weighted value, and but we can't quite do that in that way for continuous functions. So what we have to do is we have to integrate. So the expectation of x is across the whole range that we're interested in. It's the value times its probability across that range. That's where the dx comes in. Okay, so if we just work that through, I'll put a couple of steps in here, but you can work this through for yourself. That's going to give us an expectation of, or an expected value of 8 divided by 3, which we notice 2/3 the way along between 2 and 3. And in actual fact, the center of mass of a triangle is 2/3 the way along. If we wanted to find it in 3 dimensions, there we could come down 2/3 away from 2 down to 1, and that point there would be the center of mass of the triangle. Anyway, that's a little bit of bonus stuff, more to do with calculus really than probability, but anyway. Right, so that is the expectation part C. Now, it doesn't ask us, but I've kind of extended that to the variance, because if we want to calculate the variance, then what we use is this expression here, which is, it's very much like what we've seen before, is the mean of the squares minus the square of the means. So this is the version of that relates to random variables. So in order to do that, well, we've done the expectation of x here, and we're just going to have to square that. What is this? Well, it's pretty much the same thing, really. Is it, instead of multiplying by x in this integral, we're multiplying by x squared. So if we were to do that, and we just evaluate this integral, therefore, x squared times the probability of x across this range, then work it through, we get this value 43 divided by 6. That would be the expectation of x squared. So just to go back to the variance of x, and if we stick the values into that expression there, we're going to get 43 over 6 minus 8 over 3 squared, giving us this, which is 1/18. So that would be the variance of this random variable. Okay, so that was a bit of extra. The last part says, find the median of x. And what do we mean by the median of x? Right, well, the median of x is the 50th percentile, isn't it? So we have to do a bit of integration again. So what we're doing is we're saying, right, we choose a point A. We want the value of A such that this area between 2 and A is equal to 0.5. So it's quite simply that. That equation there. Right, so, well, same again, really. We can just evaluate this. The function is 2 into x minus 2, which I've written as 2x minus 4. We're going to integrate that and just follow the equation through. Again, you can pause the video, work this through for yourself, but that's eventually going to give us a value of A, which is equal to approximately 2.721 decimal place. So the important thing there really is to note what we mean by the 50th percentile, and it yields this equation. And obviously, in this point, in this situation, this value A is the value to be found. Okay, so that is a kind of nice example, I think, for a continuous random variable. We brought in expectation, we brought in the mode, we brought in the variance and the median, and looked at how integration is going to help us to find those. Okay, so thanks for listening.